Hey everyone, welcome to today's video on virtualization. Whether you are a beginner or a seasoned tech enthusiast, virtualization is a key concept in operating systems that you will want to understand. It's widely used in development, testing, and even security. So let's dive in and explore how operating systems simulate environments for development and testing. In simple terms, virtualization is the process of creating a virtual version of something, like a computer, a server, or even a storage device. Instead of needing separate physical machines for each task, virtualization allows multiple virtual systems to run on a single physical machine. These virtual systems are called virtual machines or VMs. Imagine having several computers inside one machine. This is the magic of virtualization. This ability to create virtual environments is incredibly useful in development and testing because it allows developers to test different setups, operating systems, and configurations without needing separate hardware. So, how do operating systems enable this process? At the core of virtualization is a layer called the hypervisor. The hypervisor manages and allocates resources like CPU, memory, and storage to each virtual machine. Think of the hypervisor as the manager of all virtual environments on your system, ensuring that each VM gets what it needs while keeping them separate. There are two main types of hypervisors. Number 1, Type 1 hypervisors or bare metal hypervisors run directly on the hardware. Examples include VMware ESXi and Microsoft Hyper-V. Number 2, Type 2 hypervisors run on top of an existing operating system, and the examples here include VirtualBox and VMware Workstation. Both types serve the same purpose, but in slightly different ways, depending on the hardware setup and what the virtual machines will be used for. Let's look at some reasons why virtualization has become such a powerful tool in software development and IT operations. Number 1, environment isolation. Each virtual machine is isolated from others, so if one VM crashes, it doesn't affect others. This is perfect for testing, as you can experiment without risk to other projects or systems. Number 2, cost efficiency. Virtualization reduces the need for physical hardware. Instead of a server for each environment, you can run several virtual environments on one physical machine. Number 3, flexibility in development and testing. Virtual environments let developers simulate different operating systems and software setups, which is great for testing apps on various platforms without needing multiple devices. Number 4, snapshots and rollbacks. VMs often allow you to take snapshots or pictures of your system at a specific time. If something goes wrong during testing, you can easily revert to the snapshot without any hassle. To see virtualization in action, here are a few ways it's used in the real world. Number 1, testing new software or operating system versions. Developers often test their applications in different operating systems. Virtualization allows them to easily switch between operating system versions to ensure compatibility. Number 2, cloud computing. Cloud providers like AWS, Google Cloud, and Azure rely heavily on virtualization to offer scalable resources in demand to users. This allows you to rent computing power without needing to own the hardware. Number 3, security sandboxing. Security professionals use virtualization to test for vulnerabilities in a safe, isolated environment. If there is malware in a test, it can't affect the rest of the system. While virtualization is powerful, it is not without limitations. Number 1, performance overhead. Virtual machines can sometimes be slower than physical machines because they are sharing resources. Number 2, hardware dependence. Some virtualization setups rely on specialized hardware support to run efficiently. Not every machine will be able to handle high-performance virtualization smoothly. Number 3, complex management. Running multiple VMs require efficient resource management. It can be challenging for administrators to keep everything running at peak performance. It's also worth noting the difference between virtualization and containerization. While virtualization creates full virtual machines with their own operating system, containerization shares the host operating system but isolates applications within containers. Containers are lighter, faster to start, and more efficient for certain tasks, especially in cloud-native development. Tools like Docker and Kubernetes have become popular for containerization, but both approaches are used depending on the project needs. Virtualization has transformed the way we develop, test, and deploy software. It allows developers to test applications in safe, controlled environments, helps companies save costs on hardware, and is a fundamental technology in cloud computing. As a beginner in operating systems, understanding virtualization gives you insight into how software development and IT operations work in the real world. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell so you don't miss any future videos. Thanks for watching, and I will see you in the next one, inshallah. Assalamu alaikum.